Now let's look at very important concept inside VEX, which is arrays. Arrays are going to hold our information inside VEX that we can then do whatever we want with it. So for us to start with arrays, we have to understand how can we create them and all of that. So let's write for the first of all, for the array to become an array, if you have to write in first of all what kind of array it's going to be. For us, let's create an integer value array. Let's call it array. And remember that square brackets are a distinguishing factor for it. So now that we have, let's close it down. Now this is created an array. What we can do is actually print it out. Let's print it out and take a look at it. Let's just copy it. Now let's take a look at it. You can see it's basically empty. If we, after array, writes equals, and then with the curly brackets, let's say 1, 2, and 3, then close it down. You can see we now, let's clear it down. Now we have 3 values inside our array. For us to create a vector array, all we have to do is, let's copy this, and let's call it vector, and let's call it array2, and reference array2, you can see. Now we have 3 values inside arrays, and every one of these values is going to hold more 3 values in it. If you want to reference specific part of this array, we can do this by this. So let's say you want to array2. One important thing is to note that this array is going to start counting from 0. So 1 is going to be 0, the first part. 2, the second one is going to be 1, and third part is going to be 2. So if you want to, let's say I want to reference our array, second array, let's remember that it's going to be 1. So in a square brackets, you just write 1. And if you want to reference, let's say x, y, or z, you just have to write point x, y, or z. Let's say z equals, let's write 1, like that. Let's take a look. You can see now we have written inside our second part in a z pocket, we have now 1 in it. So this is how we can change the values for it. But most likely we are not going to work with arrays in this way, very directly. What we want to do is just write inside these values something like these kind of attributes. So if you want to change the entire part of the vector, we can just, without the dot z, reference that part of it. So let's say I want to change the 2 to the, let's say 10. So that's going to be 1, and then it's going to have 10. You can see now the whole part of our vector array got changed. Another part I wanted to mention is that we can actually reference multiple arrays. So now what we have made, let's take a look. We have made 1 and 3. So 1 is 2, and 3, you know, we do not have a third part of it, third pocket for our array, but you can see it's automatically created it. So if I add it at 10, you see it's automatically going to add our arrays in there where there's with zeros. It's basically going to count until 10, and where there's no value for now in our array, it's going to put down zeros, and where 10, we specify 10, it's going to be 10. Now let's try out and copy some values inside our arrays. First of all, I'm going to let's create a vector array. And it's going to be our point of the P, of the first position of our first point. So all we have to do is use the point, then 0, after that P for the attribute, and the point number, let's use a 0. Now let's print it out. I'll just copy this one. Let's take a look at the result. So let's clear it out. I'm going to do this like that. You can see we can now get our first value of our point. Now reference this array's x value, or better y value. So we know that if we want from the vector specify one value, it has to be an int value, or in this case it even can be a float, because they are not whole numbers. Float. So equals, let's specify our array with inside the square bracket is going to be 0, because that's the element that we want to select, because there's only one of them even, and then let's say y, like that. And now let's copy and print out. Let's take a look. Let's clear it. You can see it's negative 0.5. So if you take a look at any of these numbers, so let's take a look where y is positive. So the 4 should be positive. So let's write in 4. So now you see we have positive 0.5. So that's just a simple way we can reference our vector values. So now in arrays, let's get in our array all of the point values. So instead of 4, let's write our very familiar at pt none. Let's print it out. Let's take a look. Before we print it out, I wanted to show that we in the printf command we have this percentage and d, but for us for every element to be in its own line, you have to just slash n. So now if you take a look, every one of these lines are in its own line. You can see that now our array that we just created is now holding inside it 8 arrays separately, and this is probably not what we want. We want this as a one array, so we want all of this information holding inside one array. So how can we do that? So first of all, I wanted to show you some cool commands inside VEX, which is the length function. It says it returns the length of an array. If you take a look at examples, basically you're gonna give it array, and you're going to give us the length of it. So you can see that there are 1, 2, 3 vector arrays, and combining there are 9 elements in it. So let's take a look at our code and let's create an int, because it is an int. So basically it's going to return an int value. So let's create an int equals just len, and then name of our array, which is my array. I just paste inside, close it down. Let's take a look and let's print it out. So you can see it's gonna give us 1 by each one of these, because these are separate arrays inside our array that we just created. So how can we get this actually say that it's 8? For us to combine all of these arrays inside one of them, we have to use append function. So let's just create another Wrangle node. Let's take a look what it does. So first of all, let's create a function. Let's create array. Let's just create a simple int array. It's going to be 2 value. And now let's append to this array another value. So how we can use append function. So if you take a look at the Houdini help, it says that it's basically going to add item to the array or string. Since we have array, let's just inside here you just have to first of all specify array that we want to add to it, and then the value that we want to add to. So we want to, from my array, we want to add, let's say 2 or 5, like that. And now let's print out. Just copy it. Now let's take a look. You can see now it says 2 and 5. It basically has appended this value. And what's important, you can see it's in the same brackets inside it, so you know it's in the same array. So if let's say you want to now take a look with this command what's the length for it. Let's just use this one. Let's copy for print so it should be the same, and let's print out my length. See, it's now 2. Now let's use all of this knowledge that we just learned and get all of our values inside one vector, all of position values. To get this done, we have to do, first of all, create a base vector that's going to hold our information. So let's call it p position. So this is going to hold our value inside our loop. Now we want to array that's going to hold all of our information. So like that, make sure it's vector, and that's it. We don't want to give any values for it for now. If you remember, we used the for and while loops. First of all, let's use the for loop and then do the same thing with while loop. So if you remember it, for loop was pretty simple. Inside brackets, first of all, we need our counter that's gonna terminate from how many times you're gonna loop around. So let's create an int value. Let's say counter equals 0 because we start with the because point starts with 0. After that, we have to give how many times we want to loop around. So we want to loop around C as long as we have C is smaller than number of points inside our geometry. So that's an endpoints function. Make sure it's 0 inside the bracket like that. So basically it says as long as C is smaller than endpoints, you're gonna loop around in this loop. And now all we have to do is to get some out of this loop. Sometimes we have to change the C values, because if we do not change C values, this loop is going to be for infinite times, because we did not do anything to get out of this loop. So we know that our points is in sequential order 1, 2, 3, 4. So all we have to do after every loop, add to the C one value. Also not the quotes, but semicolon like that. And now for the main part inside brackets, what we actually want to do inside our loop. So first of all, we want to use our vector. So it's a p position equals getting the point value. So point function is going to give us our point value of our points. So first of all, we have to give it 0 for the geometry, p inside quotes for the attribute, and the c for the point number. So basically for every point it's going to get 0 until 7, because we increase it by 1 every time. We're gonna get point value, and then we want to append it to our vector. So I'm just gonna copy actually. So I'm going to append this value that we got to our array like that. And we should be done. Let's print it out. Once we have printed it out, you can see now we are getting all of our array, all of our values inside one array. Let's use the length function to take a look at what's the value is going to give for our. Let's just use length. Let's take a look at it. So length of an array. So all you have to do is give it its vector. So position all. Let's print it out. You can see it's gonna give us 8, which is exactly what I want. 8 is basically the number of points we have. So this is exactly what I want. Now let's do the same thing with the while loop. So first of all, let's just copy this one, because there's many lines that we can actually reuse. So for these lines, let's just keep it for now. Just delete all of this inside, because vector and array is still going to be relevant for us. So all we have to do is, so if you remember while loop, it's a little different, but it's going to do basically the same. First of all, we have to create our counter integer. So first I'm going to just create in here equals 0 like that. After that we have to start our loop while. It's a little bit maybe more understandable. So while c is smaller than endpoints and 0 like that. Now all we have to do is start our loop with the curly brackets. So remember the position and point is the same. So let's just copy it for our while loop. After that we have to say that append, also the same, actually let's just copy it. And then after that we have to remember the counter that we didn't on top of it. Actually it already start counting, so I just disabled it. All we have to do is this C++ at the end of it, so it's for our counter to sometimes end. Because if you do that, that's actually Houdini hangs up. If you let me show you, I'm going to delete this. You take a look at it. That's it. I can't do anything. See, it's going to cook up and basically crashed Houdini. So just press exit. Make sure your loop does not go for infinite amount. And now if you take a look at our printf that we had mylen, it's still 8, and let's print out our position all. You can see it's basically same values, either for while loop or with the for loop. And what I like to do, let's just select our for loop. Let's say I want to delete the endpoints command, and let's just make it, since we know we have 8 points, let's just say it's smaller than 8. You can see it's the same thing. So let's say, let's add 2 for every loop. So let's say, you can see, since we have 8, it's the same thing, but since we are adding 2 values for every loop, you can see we have created 2 times smaller our array, so only 4 values are inside it. And you take a look at it, so it should be 0, value 0, then it should be 1, then it should be 3, alright, and then it should be 6, like that. So every second value is taken care of. So what else we could do? Well, we could try out and print out only the y values. So let's just keep it at, so let's keep it at 8, and let's get our 8 values back. Let's say I want to only print out the y value. Well, for that we could print out, let's say I want to, for the 2, I want to print out y. Let's take a look, it's -5, so for the second part, so 0, let's just clear it out. Let's start counting it. So let's copy it, let's delete it, let's take a look. So what we want to do is get the second part. So this is 0, 1, 2, and the y is going to be -5. Like that, we can get individual values. But let's say I want to get the y values for all of our array parts. So how can we do that? Well, we have to already use the loops again. So let's try it out. And now if we want to just get x, y, or z information from our arrays, all we have to do is use another for loop. And we cannot use the same one or reuse this one. Well, we can use, but you cannot use the same one. I just duplicate it, because even though our array is now holding our information, this information is got from our for loop, so we cannot use it again for other purposes. So we just copy it. All we have to do is, let's delete this one and use this printf. And in our printf, all we want to do is, just like in previous videos, we want to reference our counter. So I want to C, and let's say I want to y values, and we know that our C is our amount of points, and we know that it's 8. And let's just delete this one, and let's take a look at what it prints out in our console. Let's clear it out and do it again, so you can see. You can see we have 9 values. That's because this printf, actually I didn't delete it like that. Now it's only 8. So let's take a look. Now it's 8 values for every point. And let's say I want to x values. that completely works, or X, Y, or Z, the same thing. So we could also reference the length of the, so use the ln function for our get the size of our array. So that's that. And what's cool about this, many times in wrangles you need to get information while not over, let's say, points. You can see it's basically works independently on whenever we run it over, because all of these functions are independent from what we run it over. So this is much more powerful way to work with and get the data from it. And I think for now that's it for this video. I'm gonna continue this topic for the next video, but for now I think it's already long enough, so see you next time.